What's up, NerfNet? Jeffrey here with Next Gen Nerf, broadcasting from my temporary workstation. I hope you're all staying healthy in this crazy time of ours. I wanted to give you guys a video update on the progress that's being made with the FHK76 and also tell you about that new tool I promised to talk about. So, most of the physical progress has been around the screen, which has been fixed in place in the butt of the blaster, as you can see. I've actually also created a couple plastic shims. This one is going to go right here, and this one's going to go here, which goes right up to this piece of plastic, which is going to go as is. I kind of like the organic way that this sort of covers the back corner of the screen. I have one more shim to create here, and then I have another piece of plastic to cover up that mistake there. I'm getting the plastic from the piece of material that used to be here, as well as the battery tray. These make great raw material for making fixes and whatnot. Once I get it all adhered, painted, sanded, I think it's going to look really, really cool. Now, other than that, there have been some developments on the LPA rocket launcher. If you take a look at the inside, the plan right now is to put the compressor right here. The compressor is this guy right here. It's essentially a motor that pumps a one-way valve, and this will go to the gauge that will measure the pressure so I can make it variable and control it as I see fit. If you're wondering where the heck I got this cool thing, it's actually basically the internals of a Ryobi power inflator. You can get this for like 20 bucks at Home Depot, and it's a perfect LPA pump. I can't take credit for this. It came from a friend of mine, Marquise Dominic. I will link to his Facebook page if he's got that up yet. But if not, you can find him in the Nerf Mod group. He's the one who originated this idea. So the plan is for this to essentially sit right about here. And the idea is that I'm actually working on a expanded foregrip that's gonna encompass the blaster down here. And so this tube is gonna run through that expanded foregrip all the way up to here. And then the tank is gonna be in here underneath the barrel. And then there's gonna be a solenoid that's going to come down through here, and then that will be towards the launch tube. The question then becomes, how in the heck do I get this to sit where I want it to go? Now, one solution that's used in this hobby is a massive quantity of epoxy putty. Basically fill in the space, create a void for the thing that I need to hold, and stick it right in there. Sure, that could work. But the problem is there's a lot going on in here, so space is actually going to be at a premium. I've got the LED panel that I have to put back in here, and there's going to be some wires attached to that. The beagle bone is going to have to go somewhere, and that's probably going to have to be in here somewhere. So I want to take up as little space as possible. So epoxy putty, not going to work. Option number 2, I take a caliper and I measure the crap out of whatever the heck is going on in here and try and create a 3D model and then build a 3D part around that. If that sounds like a pain in the ass, it is. Totally not worth my time, unless I had a way to know exactly what the part is going to look like, regardless of what the space it has to fit in is. And that's where my new tool comes in. That's right, clay. Well, this looks like an art supply. This is fundamentally identical to plasticine, which is a type of clay that's oil-based and is used in the auto industry to those large brown models of cars that you see them like carefully carving. That's essentially a plasticine clay. It's an oil-based clay, and it does not harden. So you can mold it and do whatever you need to create essentially a model of what you want it to look like. And that's where these come in. These are essentially clay rakes. They're designed to scrape pieces of the clay off carefully so you can build an exact model of the part. So that's my plan. I'm going to use this modeling clay to essentially create a part that will take up as little space as possible while still holding this exactly where I want it to go. And then once I've done that, I'm going to remove the part, and that's when I'll break out my handy dandy calipers. And instead of trying to measure this crazy space, I will just measure the part itself, create that in CAD, and then print it on my 3D printer. So that is my plan for the mechanical build going forward. On the software side of things, the BeagleBone has been received. I've got it set up. So the next steps here are to set up the Git repository that I'm going to use to transfer code, because while I can ostensibly attach this to a screen and program directly on it, it's just going to be easier for me to do the programming on my actual computer. I can use Qt Creator to create the user interface and have that auto-generate C++ code for me, and then use Git to put that onto the BeagleBone and have it run. So stay tuned. There's probably going to be some electronics videos coming up as I start that development process as well. Other than that, I hope you all continue to stay safe. I hope you all manage to find ways to entertain yourself during this period of self-isolation. And most importantly, I hope you stay tuned for further updates from Next Gen Nerf.